Okay, I think we're just about ready to get started. Thank you all for coming. I'm Anthony Steed, and I'm going to coordinate this tutorial. All our speakers are sitting in the first couple of rows, and then we have one speaker online. This tutorial is part of the work of a network that's called the European Metaverse Research Network. And so I'll very quickly, in just under 5 minutes, try and present. Well, I won't try. I will present the sort of overview what we're going to talk about today, and I'll also introduce the network. So, one thing we probably won't try and do is try and define the metaverse. So I think we agree that there's some sort of consensus about what this consensual hallucination thing might look like. So consensual hallucination is William Gibson's term for the metaverse. And I started my PhD roughly the same time as this book came out. So this was immensely influential on everybody from Mark Zuckerberg through to various other sort of film directors and authors. So it wasn't the first to imagine this sort of online 3D space where we socialize with each other, but also obviously gave it quite some character and introduced some people to the term avatar, although it wasn't new at the time. But this idea and some of the other things that go on in his book and the sequel about avatars are really fascinating illustrations of what would be possible in future metaverses. So some of the characteristics are that we expect it to be 3D. We expect to have access to different people across the world, and to do this in all sorts of mirror worlds and fantastic worlds that we can imagine. And to some extent, the scope of it is up to us. So in this tutorial, then we'll give you some of the learnings from this, from some experts in the area who've been looking at some of the technologies and some of the social issues for a few years now. And we've been doing this. I've been fiddling around with the technology in small scale for a while, and there's an enormous expertise in the first couple of rows. So I won't read all of these out. Everybody can introduce themselves. It'll just take time, and there's plenty of interesting things to talk about. But here's our affiliations for the recording, and I'm sure we'll make the slides available afterwards. And here are the topics where I will talk about some technical challenges. Doran will talk about AI and the metaverse. Piotr will talk about some of the machine learning technologies. Marco will be interactive machine learning for bodied interaction. Have you two agreed to switch, or is that the order?
We're good.
We're good. All right. Okay.
No,
it's all right. We'll leave it as is. That's mainly for me. so I know who to hassle to come up. And then Raoul, who's in the second row, will talk about some of the regulatory challenges, and Dov will present online as long as we can figure out how to amplify his voice off this laptop. Okay. So about the EMRN. So the EMRN is it's a network. It's an independent research network, and one of the key things that's not on the slide is sort of launched by Mel Slater, who wrote these slides, so he didn't put his name on them. The idea originally, it was an independent research project funded by Meta, and last year they it's quite broad, as you'll see from our coverage today, and it's working on running some conferences and hopes to provide a sort of network and eventually some documentation in various forms about what the metaverse is, and provide a point of interaction between people like me who like making things and people who will tell us what should be made and what to think about when we're considering the implications of this from a societal and environmental point of view. Most importantly, the conference held the network held a very successful conference last year called A Metaverse for Good. It's very well subscribed, They ran another tutorial yesterday, the tutorial to yesterday, tutorial today, and there is a large multidisciplinary paper coming out, under review and hopefully coming out in a few weeks' time. There will be another conference, and I believe that's June 10th and 11th this year in Alicante. So that please look out for the announcements of that. I don't think there's a call out yet. There's a pre-announcement who's out. Again, it'll be as broad and erudite as the last conference. So if you're interested in this area, please come to that. Okay, so after the introduction, it's me first, so we don't have too much switching around. So I'm Anthony Steed. I'm from the University College London, and I am interested in system architecture for virtual environments. I've worked on a lot of different things over the years, built a lot of different types of things, but from sort of low-level hardware systems through to sort of social sort of avatar systems. And so here is sort of 10 minutes or so of reflection on some of the technical challenges. And what I want to try and convince you is that we need to take a deeper look at the operating systems of the devices that we're running, because we have forgotten some of the things, some of the capabilities that we used to have 20 years ago in systems. So I've got a couple of leading questions at the end. Actually, I have 6 leading questions. We'll have time to think about one of them probably, which is why is software, which is quite a low-level software engineering operating system infrastructure style question. So at the risk of telling everybody here what they already know, there is a long precedent for these, and the precedents are not just because these are systems with avatars in. They are actually quite interesting technical systems. So although I've put MUDs and MOOs there and SimNet and things like that, the reason for that is they're really interesting distributed systems, right? With the systems that had at the time, MUDs and MOOs are really interesting how they work, how they're architected, how they allow different roles for people, how they allow different interaction capability, and how people control them, right? So for those who have never spent a lot of time when they're supposed to be writing a thesis, like me, on these systems, there's a community behind them, right? There is a community. There's a community between communities. So when we were using ABAMUD at our university, there were other ABAMUDs at other universities, and they all had slightly different configurations and so on. Now, right down at the bottom, we have systems we know and love where you can create content, but it's definitely under control of Epic Games, right? They say what you can build and what you can't build, and obviously some things you can't build. Okay, and in between there is a wide variety of interesting technical systems, and there is a book that talks about some of this architectural software, which I will flash past you for reference. So within the metaverse, then we have these. What we have now are awareness systems, sort of social VR systems, which are excellent, but they only deal well with. Oh, don't move. That's probably the HDMI cable. I'm going to stand here. I'm going to stand here. No. Ah. Right, I'm going to stand here and not move. Right. So primary awareness, which is in distributed systems and even metaversey terms, is about face-to-face contact in small groups to mid-sized groups, right? And then in what we're struggling with from a technical point of view, a research point of view, is just going down this list of things that we want in addition to that. So access to a group as a large space. So some of us came to IEEE VR when it was held in Verbella, which is a nice online social VR system for conferences, where they deal with up to 1,000 people connected, or roughly 1,000 people shepherded around different rooms and so on. But still, that was getting onto that system and having access to your colleagues, where there's very much a sign up, go to this link, and not a management system where you can then find other people, invite them in, and so on. It's all controlled at one point. And then we just don't have good ideas. Well, we have good ideas, but we don't have implementation for some of the more diverse interaction capabilities we need later on in these systems. So every system has a completely different way of doing publishing, persisting data, governing and access, and so on. Okay, so the ideal that we might see technically, which is open, flexible, supported by hundreds of different groups, supporting the types of things that we do day to day, and compliant with security standards is a very long way off, technically. Okay, so I'll talk about 3 areas, and I'll do each of these quite quickly, just to give you a flavour of what the problems are as we see it. The first is the technical architecture, and the key point to make here is just that a metaverse is made of lots of different services. This is a picture from this paper down here, which is hidden behind Piotr, which is quite an old paper that describes the architecture of Second Life. The paper points out, and other papers for similar architectures have pointed out, that you have a real-time, the primary awareness, right? We understand that quite well. It's all real-time. We know the network is tricky, but you have all these other services that you have to connect to that do things such as asset management, editing, identity, and of course, money, right? Second Life has money in it. So when you're talking, this system has bank grade security in it in certain points, right? Because it interfaces with the dollar, right? So you can buy Linden dollars, and of course, that's true in many game systems, right? So if you look at their back-end architectures, they are very complicated because they have to defend against denial of service through the world into the system. So there's before the book, if you don't want to buy my don't buy my book. There was this long paper that we wrote, which has a lot of the same material in it, right? So the book is about just 10 times longer than this, right? Which just goes into more detail, and it's an analysis of the sort of systems architectures and relates it to some of what was been. It's an old paper, right? But there isn't a newer sort of overview of what comes from the distributed systems world about architecture, large-scale real-time architecture. So if you notice there that the term high-level architecture, it's almost teasing the fact that that's about as extensible as it gets in software engineering terms for distributed systems. So yeah, so the key lesson here is that no one architecture fits all the systems so far. It's a long way to an open architecture because they're quite complicated. And I can't help this last dig, but if you see a metaverse company out there, they're usually trying to own one of those 4 things in that middle bullet list, right? They are trying to charge rent on naming, location, item brokerage, or governance, and all that money's been spent on trying to capture some part of the software architecture or real-time architecture, which would then become necessary. So, for example, if you could rebuild DNS and charge for it, so lots of people would throw money at you, right? Because there's a role for that in the metaverse. Okay. The next point is quite simple. It's just that the internet is not built to do metaverses. And again, this is a bugbear of mine that I've been going on about in this conference for a long time. So some things are real time, some things are not. Our XR applications are actually quite load heavy in terms of what they require from the user. So, and then some things are very important, right? So committing an important message such as I've scored a point in a game or I've spent some money relies on architectures which are, you want to guarantee certain types of guarantee over transactions, which are quite, fundamentally difficult. And we teach undergraduate computer scientists about, say, doing database transactions on slow networks, unreliable networks, requiring all sorts of complicated protocols, which we would need, right? Because otherwise people get annoyed with us. Okay, so the key lesson here is that currently the internet is quite good to move bulk traffic. The big thing that's wrong with my book is that it sort of predates the architectures that use inter data center data transfer. So if you want an up-to-date article on that, there was a paper from Meta in the most recent communications of the ACM, which is about can't remember the term, but it's sort of hyperscale architectures. And they talk about how their applications only work because the amount of bandwidth they have between their data centers. Right? So if they've got an application that uses hundreds of thousands of machines, how does that work? How does that scale? And there's a bit missing in our understanding of how things could scale, which is how to leverage those architectures, because they have fantastic bandwidth, their own cables in some cases between their data centers. And we're just using the normal internet, right? So that's a bit of a challenge when we're scaling up. Okay, then the current state, a couple of sentences, slides about this. From a HCI point of view, technically all of these platforms are very different. This is me on some of them. It's just about, if you see me in my group, that's quite easy to tell who's who. Marco will talk more about avatars, but we're more interested in usability and the sort of tasks that are required to interact with these systems. So, for example, this is a paper I wrote with one of my master's students that compares how social tasks get enacted in different platforms, because there's no conventions for that, and there will need to be. The most obvious one is plagued us for many years, which is if we've got a group in one space, in one platform, how do we as a group move to another world? So if I'm with 5 friends even in one room in Rec Room, how do I move to another room in Rec Room? And the answer to which is that each of these platforms has a very different way of doing it. It's not actually possible on many of them to move as a group. It's a commonly requested feature on some of them. Hubs got a version for doing that, and that's partly due to the fact that IEEE VR ran its conference in Hubs a few years ago. And then we were all poking around at it going, well, how do we all move between? They actually got a new room moving mechanism to support the poster session at IEEE VR. So the key thing there is that there's lots of different things going on that just mean that it's just difficult to understand how we would act as a group in these different platforms. So again, some standards there, some knowledge about best practice and so on. Okay, so none of the platforms has the design quite right. It's a very open area for novel design, and therefore I think that's where we come in as a research community. There are ways, there are opportunities to do research on the avatars, how to make these systems more accessible, what systems support trust formation, how will we make animation and interaction reusable. We had a discussion about that yesterday after one of the workshops, how to get data out of one person's systems into another one. All of this we can make inroads into. But a warning that it's quite hard to do that with commercial platforms, and an advert for our own social VR system, because I have to do that. It's sort of rules for engagement in tutorials, is we have a simple system. It's open source, doesn't, barely sits on, barely dives into any of these technical questions, but at least it gives the people a grounding to get started. Okay, and then some questions for later for the discussion if we have time. And then a leading question for me right at the end. One thing I love to talk to people about is, are we just going about XR applications in the wrong way? Are we just and then this challenge, which is in a proposal that's out at the moment, is why is any XR application single user? I know why technically, because programmers are using Unity, but technically why, thinking about what you're doing, do you really need to know how many users you have in an application to make it work? Okay, right. So at that point, I'm going to stop. I'm going to invite Doron to come up. I'm going to switch slides quickly and I recommend not moving. Stand here, don't move.
Hi, everyone. So my PhD was submitted about 21 years ago. It was about AI and virtual environments. And then AI at the time was very limited. But now, of course, I mean, if you're in this room and you're doing VR, maybe you haven't heard, but there has been quite impressive breakthroughs in AI, which I'm very fascinated about. So in the last few years, I got back to this field, and now we're trying in our lab to put things together, and I'm going to talk a little bit about that. And so, of course, there's a lot of strategic ways in which AI can play if and when this kind of vision of the metaverse emerges. Of course, in augmented reality, it's a device that has, built-in intelligence and scene understanding. So I think Piotr will talk about it a little bit later. And then, of course, there's avatars, which, they have both a mind and a body. In this conference, I think there's a lot of talks about the body of the avatars in motion, and Marco will talk about that. But of course, there's, agents, which are, classic AI problems. But I chose today, so these topics are already covered very frequently. I chose today to talk about 2 points that take it to the next level. When we think about the metaverse in this tutorial, we think about a society, right? About a large group of people. And I want to make 2 lessons from social media. Okay, we think about the metaverse as maybe, maybe 3 years from now, maybe 30, maybe some kind of evolution of social media as it is today. And this raises 2 points. One is very simple, which is, if you look at the success of the internet and later on the success of social media, well, with all due respect to premium content, it's the users building the content or the participants. And this is very clear, but not discussed enough sometimes. And so, okay, now I'm going to show you a short movie. And it's not a very good song. It's not a very good movie. It's just to wake up the audience in the morning. I'm going to show a few more seconds. Okay, so the only thing incredible about this video is that this was submitted as a homework assignment, So it's getting to user-generated content. A student in university, by the way, social science students, not technical, took some kind of AI package, maybe Luma or one of these packages 2 years ago already, transferred the video into Unity and submitted it. So, I think this is, well, I hope the message is clear. AI can generate virtual worlds, can allow people using transfer from images and video to user-generated content. Once that happens, we're going to have much, much more content. So that's, I think, one of the interesting drivers. The second one, of course, is text to VR scenes. Of course, eventually you might have both. You'll have an image and a video and a prompt, and you say, okay, this is a video I took in Malo, and now I want the virtual world to reconstruct our experience, whatever. So we're getting there. In case you haven't been following it, the last few months have been quite interesting in terms of text to video. Okay, still not there, but getting very interesting. And, sooner or later, I mean, there are additional challenges when you're talking about 3D or whole scenes. Definitely not here yet, but I think this could be amazing. And one of the projects that we are working on, and there will be a demo in the Guest XR booth, which you are invited to, is based on an engine that we have developed in the lab, where you write a script. It's a social scenario. It's not an end-to-end general system for text to VR. It's just for scripts with avatars. But you write a script, describing dialogues and nonverbal cues for as many people as you want, and you press a button and you get a VR scene. And this allowed us to generate 30 episodes. Okay, so this is not like in 1 week. Okay, you develop the engine for 6 months, but then, or whatever it takes, but then you can quickly generate these kind of social, either passive or interactive scenarios. So I think that's the easy and straightforward comment, which is AI is going to allow much more content in the metaverse much easily. The second point is a bit more delicate, but it may be also important. So the way I want you to think about social media today, I want you to think about it as a learning system, okay? So this is reinforcement learning. For those of you who don't know, it's the framework which is dealing with an agent in an interaction real time in the environment. It's still one of the hottest topics in AI. For those of you who have not followed the field, this is the difference between GPT-3 and ChatGPT. There was next word prediction, and then there's post-training with all kinds of algorithms, mostly inspired by reinforcement learning. And if you think about it, so this framework, for those of you who are not familiar, there's an agent that is exploring the environment, taking actions. And then there's the environment is giving two kinds of information to the agent, which is, observation or the state of the environment or a partial observation, and also a reward, a cue, and the agent has to maximize its accumulated rewards over a long horizon of distance. So I suggest we can look at social media today, even though, I'm not saying the companies behind these social media are using reinforcement learning, but we see this kind of feedback loop. And we take Facebook, for example. So Facebook is the agent. The actions it takes is deciding which content to expose which user, right? And then the environment is us, humanity or the society, okay? We are the environment for the agent, which is the social media. And the algorithms today of these companies are trying to maximize, it follows what you are doing with the content. In the case of Facebook, it's likes and shares, and I think it's also tracking, how much time you spend on each content, etc. So it's becoming very clever, at least in the last 5-10 years. And then the question is, what objective function is this agent trying to obtain? What is the goal of this learning system? Of course, the goal is to get us engaged, right? So it's a relatively innocent goal, but we know today that it's become quite successful. And there are side effects that I don't think the companies intended them, but there's a lot of problems. Again, I don't want to spend time on this with social media, right? So now we're thinking, okay, if we still have time to build a metaverse, unfortunately, Zuckerberg's attempt seems like it is held back for at least a few years. So maybe we have time to build a metaverse properly. Maybe we should try even a European project with Anthony's system. We have time until the big players get into it. Then the question is, how can we build it better? And this is also where AI. So the simple idea is we should think about this kind of as an intelligent system, and maybe we can configure the AI to basically aim at different objectives which are more desired. So we explicitly control the objectives of the society we live in, or the metaverse, instead of the corporates, okay? And this is what we're doing in the Guest project, which is a European project. And so the process is as follows. To make it simple, the process is as follows. In order to train deep reinforcement learning agents, of course, it's not ethically and it's not also practical to try it with humans, because you need millions or many millions of learning steps. So we build a simulation. In fact, our partners from University of Warsaw are building all kinds of social simulations. And then we, in my research group, are building AI deep reinforcement learning agents that learn to obtain pro-social behavior in these social simulations. And only then we can transfer it to multi-user VR or multi-user XR, okay, with real people. And so it's a very interesting research challenge, which goes beyond individual avatars. It's very, very ambitious. We have only partial success. So we've done very interesting we've done very, very interesting, more kind of theoretical, or I would say basic AI research, where we model a lot of social situations as social dilemmas. You know, it's either the prisoner's dilemma or temporal spatial versions of, maybe there's even a video here. So this is like a game where agents collect apples, and it's an example to study a lot of problems in social dilemmas, fighting over resources. You see that if the agents become too successful, then they are depleted of resources. So this is a good model of many problems. By the way, a paper from DeepMind from 2017 about multi-agent behavior, studying basically emergent social phenomena. Now, what we have done in the guest is we said, okay, we have these multiple agents, but we also add a regulator, or, you know, we didn't want to call it a regulator or a boss, so we called it the guest. But we add a meta agent, which tries to achieve, you know, in addition to our individual goals, there is an AI that is trying to manage pro-social goals or the group's goals, okay? And the system works together. So just to keep it simple, Piotr is hiding one of these graphs, but yeah, whatever. Okay, so in the original paper, there are 4 metrics. There is, for example, efficiency, peace, because they introduce some violence where agents can shoot each other to gain more apples. And then there's equality, sustainability. So this is a model to study a lot of problems. And with our agent, again, hopefully this works. Oh, no, it's Piotr. Okay, so with our meta agent, to keep it very simple, look at the red line here. We said, okay, we don't like violence. You know, we're in the Middle East. We had too much violence. So we give it as another secondary goal to the simulation. And you can see that the meta agent affects the individual agent indirectly, okay, without communicating them. They learn that they are not supposed to compete, yet they retain the same amounts of efficiency, sustainability, etc. Very long story with a lot of very, very interesting details. But I want to bring it home back to XR, okay, to more concrete. So these are kind of abstract simulations, spatial temporal with agents. So we think it's a good model for the metaverse. But eventually, we're also doing XR. So this is a simulation for moderating. Mostly, the idea is to look at turn-taking in group discussions, okay? So you see deliberately in this particular research, we don't look at text, okay? We don't care about the content. We have other students working on, of course, language and language discussions. But in this case, see the agents say things like blah, blah, blah to each other. But this is a simulation that the Polish group built. But you see it's about gaze, turn-taking, okay? And then our agent learns in the simulation to achieve all kinds of goals. For example, maybe there is someone who does not participate enough in the meeting, maybe because they belong to some minority group, or maybe you want to achieve more efficiency, you want to get the discussion more lively. So you could have these kind of criteria, metrics. In fact, the Polish group have a very interesting finding. I think it's their finding, but it might be something well known in the literature, which is that if you want a good discussion for brainstorming, you want to increase the entropy. It's like you want to have a variable or a high entropy in the talking order of the people. Okay, so you could set that as a goal for the simulation. So everyone wants to achieve their own, you know, in this case, the resource is time, okay? Everyone wants to achieve their own goals in the meeting. Some people are competing for time, and you want to make sure that this is covered. And then after training on these simulations, we can have the agent in XR, and this is more or less what it looks like. With VR United, the platform for Mel's group in Barcelona. And you see the agent is this Albert Einstein, this wise guy sitting in the room with you. So we have Ramon. Hassan and Ophir from my group. And 2 more minutes. Yeah. You see Einstein changes gaze. There are all kinds of interventions that Einstein can make. One is gaze. It's like a subtle cue that maybe you should take more part in the conversation. Can also control other people's gaze because it's the system. And then in some cases, I think it's in the video, if someone is really, really quiet, Einstein can turn to them and say, well, Marco, what do you think about this? I think, anyway.
Maybe it's two of us talking and then Ramon doesn't talk, let's see if actually it will turn for Ramon.
Okay, Ramon is quiet, so Einstein is looking at Ramon. Anyway, at some point he speaks as well. So again, the goal in this demonstration is to show very subtle nonverbal interventions. Of course, with language you can do much more. And so I hope this gave you a sense of things that are even beyond avatars, I would say, which already are a huge challenge. Okay, and now to you, Piotr.
You should cease the screen sharing by dawn. No? Click on your side.
Yeah, sorry, it's fiddling. Go ahead.
Yeah, seems to be okay. Yeah, now you should see the people in the room. Okay, so after a small technical troubles, we can start my part. I'm Piotr Krzyczyński. I'm from Poznań University of Technology, and I will follow more or less the talk by Doron, but in a much more technical tone, because we have a lot of possibilities to use artificial intelligence with the use of XR, MR, and metaverse, of course. But we need to provide proper technology behind this to make the system usable and safe. And there are two aspects that are most important in any system that has to be deployed with a lot of people. They have to be usable and they have to be safe. How to do that? So, first of all, what we can do using machine learning in mixed reality or augmented reality or virtual reality or extended reality, anything X, as you know, which can be a part of the future metaverse. First of all, we can improve the perception because some people have some problems with the perception. Some people because of their problem with sight, some people because of their mental problem, some elderly people, maybe some children that can be in the spectrum of autism and things like that. There is a lot of potential users of metaverse that need some help on the perceptual side. Yeah? So these can be pretty easily provided via existing machine learning algorithms. Yeah? Because a good share of work on machine learning was devoted till now for object detection, recognition, segmentation, and things like that are all about perception, mostly visual perception. However, we have some algorithm that can be also adapted to other perception modalities like haptics, but those modalities are still not fully used in the metaverse. And so we will focus on the visual part. So if we have those algorithms implemented in our system, we can provide a better perception. And by providing better perception, we can provide more informed decision-taking to the users. So they will be more informed, and because of that, they can make a better decision in their metaverse environments and of course in their applications, even if those applications are single user applications. Like in most of applications, I will show as use cases here, because this is still not promoted to the metaverse version. There are proof of concepts that are for a single user as far as I can say, show you those examples. Here you can see a video showing the possibility of detecting objects in augmented reality. Actually, the platform used here is Microsoft HoloLens 2. Few words where we choosing HoloLens 2. Well, everybody knows that HoloLens 2 is already not supported. At the end of the last year, Microsoft told us that they will no longer develop HoloLens. They have changed their policy with respect to involvement in XR or mixed reality. They will focus on software, on add-ons for their Teams platform, so on. But I think that still HoloLens was and is one of the best platforms for doing things like that, because it has a quite a powerful computer inside, which is the Snapdragon. It's a holographic processing unit that is used for some special information processing, but can be also used for good of speeding up machine learning algorithms. And first of all, HoloLens has an enterprise level cybersecurity. So it is quite a secure, let me say, more secure than most of the solutions from Meta I have seen till now, because the Meta is focusing on end user market, gaming environments, things like that, social networks. And they are collecting the data, but they do not let user to use the raw data, like for the machine vision algorithms we need for this kind of application. So we decided to implement this on HoloLens. And the main idea was to implement this in a fully embedded application. And so this is a kind of edge computing. So we don't need a server. We don't need external laptop to tether to this laptop. Everything is processed inside of the HoloLens goggles. This has two very good consequences. First of all, it is faster because there is no delay because of transmission of information. Yeah, we are not depending on the internet. Today, you have an opportunity to see what could happen if we have a slow internet. Yeah? So this could also happen, as also Anthony mentioned, that it is very important to have all those transactions in real time. We don't have this problem here because everything sits inside of the HoloLens. Yeah? The second thing is the security. As I said, everything sits inside of the HoloLens. So there is no possibility to leak information outside. Yeah? Even if my application is using some data that are private, that should not be leaked outside of the given application, then it is technically not possible that this information will be leaked because it is not transferred to outside of the goggles. Yeah? So because of that, we have used this approach. To implement this, of course, we required to transform this model, which is very popular YOLO network. That is, you only look once. That is version 8. We experimented with several variants like YOLO 8 Nano or YOLO 8 Small. For the particular application I will show you on the next slide, it was YOLO 8S, YOLO 8N, that is a nano version, the smallest possible. So then it was transformed to the common format of neural network models, and then it ran on a Barracuda library, which is an add-on for Unity that makes it possible to inference a neural network inside the Unity application and, in fact, inside the augmented reality goggles. Of course, we needed also some calibration and also some work to put this object we have defined in the proper place on a display. And another thing I should say a few sentences about is how we have trained this system. Because having a YOLO object detector trained and even run on a very small computer is maybe not an achievement. But our system is based also on a foundation model, because we didn't try this for specific models, but we have used a segment anything model, which is, by the way, from Meta. And this is a computer vision segmentation model. It's also good for object detection that can segment arbitrary scene and does not need to be trained purposefully for a given object. We can also retrain this to make it even better, even more efficient, and we can use a prompt to point out a particular object. So because of that, our system is quite adaptive to different environments and different scenarios. What we have tested this system on was searching for objects in a workshop. So a person is entering a workshop and is interested in a given object. This is said before, okay, you are looking for this or for a screwdriver or a hammer or something like that. And wearing the HoloLens, the person finds the given object. This is in real time using only the goggles. We don't need any other sensors, any support from outside. And results are interesting because while the technical part of the application works as expected. So we have a real time, we have a generally good accuracy of detection of objects with a few false positives. Then the user feedback is not good. So the time spent by the people wearing the HoloLens to find the object was not shorter, or in many cases even slightly longer than without the HoloLens. Why did it happen? Because something wrong happened not inside our system, but between the application and the user. So the acceptance from the user was not that good as we expected. So I think this is an important hint for building the metaverse applications, that we need to balance the cognitive load of the users adding any AI to our applications. Because if the user is overwhelmed by a hint, there are some false positives among them, then the trust of the user in our AI application is lowering. Of course, there are also some technical problems like the limited field of view when you are wearing the glasses. Also, there were complaints from users about this. So finally, we can say that while it was possible to show that this is a technically viable application, then we still need work on the user interface and the scenarios, how to help the people to use the hints from AI in real applications. The other real application we have implemented, also as a part of a grant we got from Meta, was a system supporting origami folding. The ancient Japanese art of origami is, of course, very popular. Everybody know what it is. I don't know if you have some hands-on experience with origami or not, but it is not too easy to fold down the object just looking at a 2D instructions in a book or in the internet. So we have implemented the system also for a HoloLens platform, because it is more or less the same technology behind, under the hood, helping people to fold the origami models. What is new and what is different with respect to the previous ones? In this case, we not only detect the object, but we detect the state of the object, or generally the state of the scene. So the state is changing as users fold the object, and we are constantly telling if the state was changed from the good one to the next one that is proprietary and is the good one for a given scenario, according to the planned object to be done. Okay. With this, we also had the same problems. And the last thing we also implemented is a system for helping people in rehabilitation. And this is also based on the same technology. Everything sits inside and is making possible to follow the path to train your lower limbs if you have some problems that need to be rehabilitated. Yeah. So finally, there is a list of what is important. As I said before, important is the balance between the accuracy and the speed, but also security is very important. Yeah. So for security, we should attack this not only from this network architecture side, but also from the side of machine learning, because some machine learning models can be poisoned by the data. So we have to ensure that this is not the case. So let me conclude with some messages and also some open questions you can ask. Maybe this is a hint what to ask. And finally, a slide with some papers we have used, particularly on this technology of embedded machine learning models, some our papers, and maybe the most important line on this slide is a GitHub with this solution. If you want to use this for your applications, feel free to do that. Thank you.
Okay, everybody, can you hear me? Great. Hi, I'm Marco. So I think my original title was sort of interactive machine learning and embodied interaction. We've had quite a lot about machine learning, so I'm going to focus more on the embodied interaction aspect and the social embodied interaction aspect. Okay. Okay, just briefly, I'm part of the CVR lab at Goldsmiths University of London, together with Sylvia, who many of you probably know. And sort of, I'm going to name check, but actually she's walking in right now. I'm going to name check various people in this group later in the talk. Okay, so this is the question. Why do we need the metaverse when we already have Zoom? Okay, there's lots of answers to that. I'm going to focus on, why do we need something different as a way of having social interactions with people at a distance? Okay, so isn't Zoom perfect? Okay, why not? Okay, so the core is non-verbal cues. So sort of this was a image I generated from Midjourney, what it thinks non-verbal interactions like. So what our interaction with other people is far more than the words we say. The non-verbal body language is very important. This includes gestures, posture, how we use our body in interaction, how we face other people, our facial expressions, our gaze, whether we're making eye contact with somebody or not. So these are really important parts of this. And often the first thing that people think about when we say all this stuff is emotional expression. And yes, that is part of our interaction. But actually, a lot of our conversations aren't particularly emotional. A lot of it is actually about regulating the interaction. So things like turn taking. So who is the next person who's going to speak? Or, is somebody understanding me? Or, do I need to carry on talking more? Okay, I've put these last two in purple because they seem to be things that Zoom might actually do better than current metaverse applications. But actually, there's a sort of big problem again with sort of video, is that eye contact and therefore a lot of facial expression and a lot of body language doesn't work because the camera and the screen are in slightly different places, so that when you're looking at the image of another person, they're not seeing you looking at them because you're not looking at the camera. Also, social interaction is very spatial. These examples called F formations, which are the ways in which we stand and arrange ourselves during social interactions. And you know, if you go out to the coffee breaks, you will see people standing around in various groups like this, and how we use our body spatially is really important. So you'll see, you know, particularly in bigger, larger groups, if I'm turning towards one person, that means I'm paying attention to them. And VR and the metaverse 3D is very good at that. Okay, I'm gonna sort of briefly talk, and I haven't started my timer, so I have no idea if I'm late or not, about the two types of people that we have in the metaverse. So we have avatars. Avatars are 3D representations of real people, and they're directly controlled by that person. So I don't need to explain what an avatar is. And we have agents. So these are computer-controlled characters, and you know, they're controlled by AI, whatever that means. That could be really super simple AI, or it could be sort of the latest high-tech stuff. And I'm going to talk a little bit about each of those. So avatars, you know, the nature of our avatars is super important. This was a study we did with Microsoft Research that was looking primarily at the visual appearance of avatars. There's a lot of work on the visual appearance of avatars. But as I've just said, the actual behavior is even more important. So, you know, how we've got our body language is vital. So actually a lot of work when we're looking at avatars and getting avatars that work really well is to do with tracking. And this is Fang Ma's work with Sylvia here at IEEE VR a couple of years ago, looking at how you can use the face tracking capabilities of the Vive to, you know, animate avatars. And then I won't go into details of the study itself, but how it impacts social interaction. And again, won't try to explain this, but there's lots of complexity going on. You know, this is simply tracking facial expressions and accurately reproducing non-verbal cues from a real person to an avatar isn't simple. So what about agents? Right, well, LLMs have solved agents, right? They've solved everything. No. Because what we come back to is what I've been saying at the beginning, that our social interactions are not just about the words. They're about, you know, body language, everything, you know, even tone of voice isn't captured by LLMs. So, I mean, we did these slides after sort of a grumpy old person conversation in the restaurant yesterday with Vinoba Murthy, and it's like, loads of people, you know, this kind of thing old people said. We did this 20 years ago and nobody's, you know, people still haven't taken this on. So you can have very, very simple models of nonverbal behavior that can really change how we, you know, how we feel about a virtual character. And at least twice in my life, I've completely freaked myself out by simply implementing a very simple eye gaze model, right? So a model in a virtual character that just basically looks at me an appropriate amount of time as I'm speaking, you know, similar to this one. And, you know, I will be there sort of, you know, like just coding and trying to get this working, and I'll go into VR and I've got a virtual character that's just doing this or just doing this, or, you know what it's like. And then suddenly it works. And I was like, you know, I was going in and saying like, go to VR, say hello. And then suddenly like this character talks, like, you know, turns to me and looks at me in the eye. And I'm like, oh my gosh, this is a real person. Like I just had this sort of instant visceral reaction. And this is what happens. If you get even very simple but correct body language working, the sense that you're talking to a real person just sort of ramps up massively. So it's really super important. And this is more than 20 years old. It's a really simple model. You can download this paper and implement it on top of an LLM, and you'll have an LLM-based virtual character, and you'll have something that starts to feel really, really real. Okay, social interaction is not just one way, and this, it is an interaction, and that's not just verbal again, that's non-verbal. Our non-verbal behavior responds to each other. And if we're getting more sophisticated in the model, I said in the last slide, the hard part is sensing the users, so sensing the real humans, what's going on there. So in a sense, what I think is one of the interesting things to look at right now is understanding the social cues that people are bringing into virtual environments. So we did a study with a project with some game studios, and the person there is Christina, who's the PhD student who did a lot of this work. And she was looking at, can we tell whether a virtual human was paying attention to a virtual character? So a real human was paying attention to a virtual character. So we essentially threw some gamers into VR, and there's a virtual character doing a monologue. And because they're gamers, they completely ignored the character and just started like throwing bits of the furniture around. And okay, then we put them in again and said, actually, this time you have to gain the trust of this person. And so they actually started like listening to her and responding to her. And then we trained a machine learning model. So this is just one example, but there's, this is where the AI machine learning becomes really useful, is understanding what is happening in there. And then the response from the avatar, actually, we've got lots of technology that's really good at that. I'm not saying there's not innovations we can make, but it's actually really understanding what the real people are doing in this scenario, which is the harder problem. So we've talked a little bit about generating and sort of creating body language for virtual agents. Is that just for virtual agents? Surely avatars, we can just track people and reproduce it. Well, no, because tracking cues, are imperfect. This is kind of all we've got with VR, hand tracking, head tracking. There's a lot more body language than we've got there. So we need to sort of infer and generate, generate body language and reproduce it to make it richer, which is kind of difficult because we don't want to sort of fake it too much. But again, this comes back to the idea I talked about earlier that, well, it's not just about emotions, like trying to sort of infer emotions and, produce emotions on characters might not work. Especially, I just, remember like some of the meta avatars would just randomly smile at you, and it's like, okay, I'm talking about a really, sort of difficult time I'm having at work here. Don't just be grinning at me. That's inappropriate. But some of the sort of the more turn-taking, the more sort of social regulation aspects of it can work. And in fact, this original gaze model from 20 years ago was for avatars, not for agents. It was like reproducing a gaze model where we didn't have gaze tracking, but based on speech. Okay, so the last thing I want to, okay, I'll be quick. So the last thing I want to talk about is embodiment. Tabitha Peck did the great keynote, but I'll move on from her work. So I think hopefully you're familiar with the idea of embodiment, having a virtual body in VR. So this is a key part of having an avatar. And this is like really, sort of impactful. So this is a study that my colleague Tara Collingwood-Williams did that showed that, having an avatar, has a big impact both on your own behavior and other people's behavior. And importantly, the worst conditions were inconsistent. If one person had an avatar, but the other one didn't, things went wrong in a variety of ways. I won't go into the details. We've done studies related to what kind of bodies people can embody. And actually, we've done this. This is my colleagues at the University of Durham, developmental psychologists, Dorothy Cowie, looking at, we more readily accept things that look like hands than look like crosses, but actually kids are more accepting of it. So there's a lot of variational factors that impact body ownership. But there's two just things that I'd like to say about interaction and its effect on us in terms of embodiment. So the embodiment is like, it's not just affecting the other people, it affects us. One example here is Xiaojing Li, who's here. If you want to find out more, go and find her. But she was looking at sort of smiling as an interface into virtual reality. And if you made people smile because that's how you interacted with the experience, actually they got happier. So like our low-level bodily actions, improves our mood. So actually, if you're having to, if the system is tracking your facial expressions and your body language, so you're having to be smiley and happy, you're going to feel better about it. And then last one, this is Claire's work, among others. She's also here. Say hi to her, Yuka. How embodiment also affects is a good sort of measure of our interaction methods. And this is a study where, okay, how can we interact at a distance? The go-go technique, if you're familiar with that, from Doug Bowman. What if we can stretch our arms rather than shooting a laser? What if we can stretch our arms? And again, stretching, having sort of extended limbs improves embodiment. It improves presence. I don't think we looked at presence in this study, but another one we did up to a certain point. But if it gets really far, then we're not, we're having worse embodiment. So actually, you can do stuff that's beyond human capabilities up to a certain point, and it can still feel embodied and natural, and that's a really powerful aspect of VR. Okay, I'm going to stop there.
Good morning, everybody. My name is Raul Ruiz, and I belong to the Metaverse Center of the Academic Center for the Responsible Development of the Metaverse, where we take more of a legal approach to the responsible development of virtual environments. And that's precisely what I'm going to debate here today. I'm going to address some of the regulatory challenges related to the deployment of virtual environments in the Metaverse in general. So we've heard it like plenty of times. The metaverse is being depicted as the next phase of the digital economy. This vast interconnected network of virtual environments where people are going to interact, they are going to work, and they are going also to conduct transactions. And ever since Facebook, now Meta, announced that they were turning their development efforts into the metaverse, this technology has had a rapid growth projection. And not only that, we've seen it in this panel, we've seen it over the last days, augmented and virtual reality applications are increasing exponentially. And they are not only related to the health field, but also to other areas such as industry, manufacturing, education. So now, considering the wide and the quick evolution of this phenomenon, a fundamental question arises, or at least a fundamental question from a legal perspective, which is, how are we going to regulate the metaverse? Or more precisely, which rules and frameworks are going to govern its overall deployment and its daily use? And also, are these rules sufficiently adaptive to the particularities posed by these technologies, or on the contrary, should they be updated? Well, I will admit beforehand that this is too much of a complicated debate for a 15-minute presentation, and there are many layers that can be addressed. But I will try just to give some brief introductory notes in order to illustrate this issue. And in order to do so, I think that a good approach is to view this problem from the lens of the so-called platform economy. So for more than a decade now, the digital economy has been controlled, has been shaped by platforms. We're speaking of intermediaries such as, for instance, social media that provide these infrastructures, allow users to connect, and also set their own governance frameworks. And when we stop to think about it, actually many virtual environments such as Horizon Worlds, Sandbox, Decentraland, etc., they all kind of fulfill this very same role of providing infrastructure and allowing for the connection of users. Okay, so what we need to take into account is that usually these platforms not only provide infrastructures, but they also act as de facto regulators, meaning that in their terms and conditions, they are going to establish the rules and norms and standards that are going to condition the functioning of these virtual environments. And users, when they access these environments, they are implicitly agreeing to this contractual arrangement that eventually will rule their rights and obligations within the platform. This is not to say, however, that platforms can do whatever they please. And of course, there are national and international standards that we have to take into consideration, especially in two different scenarios. First, when these terms and conditions have not foreseen a specific situation, no, we can say that there's kind of a loophole that still needs to be addressed from a legal perspective. But more importantly, in those cases in which these terms and conditions go against public policy norms. In those situations, we're going to need to take a look at national and international standards. And recognizing the metaverse as part of the broader platform economy actually allow us to identify certain key European digital regulations that become relevant. And in this presentation, I'm only going to address two of them, the Digital Services Act and the Digital Markets Act, given the role that they play in shaping online interactions and market dynamics. But of course, there are many others that are still relevant to the deployment of the metaverse and the challenges it poses. And these challenges refer, first of all, to content moderation. Because we know that in traditional online platforms, unlawful or illicit behavior can usually take the form of audio, text, video. However, the metaverse is going to introduce more real-time dynamic interactions, which include verbal communication between users, also the behavior of avatars, their conduct, their gestures, and last but not least, the manipulation of virtual objects. So it is true that this instrument, the Digital Services Act, includes a lot of content moderation obligations that companies have to fulfill, that platforms have to abide in order to identify and remove illegal content. However, these traditional mechanisms do not sit well with the immersive and instantaneous nature of the metaverse, okay? Because, for instance, real-time interactions are going to make conventional content moderation mechanisms less effective. Then we also have the fact that illicit conduct or behavior or content is not necessarily going to take the form of audio, text, or video, but may manifest as virtual harassment, verbal abuse, and also even the inadequate behavior of avatars. And last but not least, even if we focus just on these ex-post moderation mechanisms that have been foreseen by the Digital Services Act, we may not be able to enforce them if these platforms do not record everything that happens within their ecosystem. So that's those are important issues that arise in relation to content moderation. And in order to circumvent them, platforms are already starting to adopt certain measures. So for instance, we've seen it with personal boundaries in Horizon Worlds. You can now activate these boundaries that will drive other avatars away and therefore avoid inadequate avatar behavior. Then we also have real-time user reporting systems so that users can notify the illicit conduct or behavior as it is happening in order not to wait for it to be over. And last but not least, we also have AI-driven behavior analysis in order to identify, to predict, and to prevent unlawful behavior before it happens. However, of course, these mechanisms also pose certain legal challenges. For instance, when it comes to privacy, our platforms constantly monitor the behavior of users within their ecosystem. Then also we have censorship. At some point, this AI-driven content moderation actually overpolice the behavior of users. And last but not least, discrimination risk, because at some point, these algorithms may identify certain groups as more potentially in favor of committing an unlawful behavior and maybe discriminating somehow in that sense. And another key issue that we have to add to all these complications already introduced is the fact that when it comes to virtual environments, we have several governance models. So for instance, when we speak of more centralized platforms like Horizon Worlds, we are able to identify one main legal entity that will be in charge of accountability and enforcement. But what happens when we speak of decentralized metaverses like the Decentraland, which are usually run by the decentralized autonomous organization? Here we do not have one legal central entity that is in charge of the deployment of the metaverse or the virtual environments. And therefore, accountability and enforcement turns a little bit more complicated. And this is something that will have to be addressed by the legislature in the future. And then when we turn our analysis to the so-called Digital Markets Act, just to give you some quick introduction, the Digital Markets Act, basically what it aims to do is to prevent dominant tech giants, to which it refers to as gatekeepers, from monopolizing the digital economy. In order to be qualified as a gatekeeper, there are certain requirements that have to be made. I'm not gonna go too much into detail, but for instance, the service has to have more than 45 million monthly active users in the European Union, or it needs to be a core platform service provided for more than 3 years. Now the question is, why is this relevant to the metaverse? Well, precisely because once a service that is provided by a platform has been identified as a core essential service run by a gatekeeper, the gatekeeper is going to have to fulfill certain obligations, including, but not limited to, allowing third-party app integration within its ecosystems, ensuring fair competition between the business at play in its digital ecosystem, and last but not least, providing non-discriminatory access to digital markets. Well, there are some voices that say that this openness and obligations contained within the DMA may actually help to solve one of the main issues that has been highlighted in relation to the deployment of the metaverse, which is interoperability. For instance, transferring your digital assets or your digital avatars or identities from one metaverse to another. And it is true, we know it that as per today, most metaverse platforms operate as closed ecosystems, meaning that users cannot transfer the digital assets nor the digital identities. We also see that they are usually forced to resort to certain currencies or payment methods. And last but not least, we see that the companies that control those metaverses impose restriction conditions on third-party services. So as per today, no metaverse platform has been identified as a core essential service provided by a gatekeeper. However, this is not to say that it may not happen in the future. And indeed, if major players like Meta's Horizon Worlds or Apple's Vision OS actually get to dominate the market, they will be subject to such obligations, in order to prevent them from restricting competition and from exercising an excessive control on the metaverse economy. And which is important and highlights the relevance of the obligations contained within this digital instrument. However, there are also some other voices that claim that the interoperability obligations contained within the DMA are insufficient because, as we have seen, for instance, in Anthony's presentation, the deployment of the metaverse requires many more interoperability layers than just allowing third-party services to be integrated within your ecosystem. And last but not least, we have the same issue here when it comes to decentralized metaverses. Who is in charge of the deployment and fulfillment of these legal obligations? Who do we have to resort to in order to make sure that they are being fulfilled? So again, this is probably something that we have to address by legislative or policy efforts in the future. And just to provide with some final remarks, the metaverse is growing quickly and rapidly. And while the Digital Services Act and the Digital Markets Act do provide, let's say, a good starting point or some good regulatory tools, their application to virtual environments is still a work in progress. There are, moreover, many other issues that have not been addressed by these instruments. For instance, when it comes to intellectual property, we also saw it, for instance, with content generated by users and everything. Privacy concerns, what happens with personal data collected, especially when we're speaking of sensitive data. We also have this pending issue of the legal status of avatars and what happens with their behavior, legal rights regarding avatars, etc. And all these issues will have to be eventually addressed by the legislator. Overall, I think we could say that the European Union is kind of in a delicate position, because on the one hand, it has to guarantee the rights of users, and it has to protect competition and ensure fair and non-discriminatory access to digital markets. But then, on the other hand, it also has to prevent that a too rigid legislative framework actually hinders the deployment of the metaverse. Because a too strict, complicated regulatory framework will actually just prevent such deployment or just drive users and developers to unregulated alternatives. But then on the other hand, if we have a framework which is too permissive, we just may end up eventually with a fragmented, unsafe, and monopolized market, metaverse market economy. So the European Union itself has acknowledged this tension in its 2025 competitive compass. I don't know if you have the chance ready, but basically it says that it aims for a simpler and lighter and faster and bolder union that at the same time retains or still adheres to its core fundamental values. However, whether and how this vision will eventually realize, it's something that yet remains to be seen, but of course, we will try our best to bring you all the information as it develops. And just to conclude, what I spoke about today is just a sneak peek, just a teaser of many of the issues that we have spoken in our working papers. So if you're interested in such issues, I would actually recommend you to go to our webpage and just consult their papers, because they are actually excellent, and I'm not speaking about mine, but about my colleagues. And then, as Anthony indicated at the very beginning, we're also having another congress, the second congress, which we are organizing together with the EM on the 11th and 12th of June. And actually, we already have the call for submissions out, so please feel free to send your submissions and feel free to come. I will assure you that Alicante is a very nice place to go in June, and we'll make our best to take you to the best beaches around the town. And that's all on my side. Thank you very much, and I'm available for questions.
Last speaker is Dov.
Hi, I'm here. If I could just share my screen. Here we go.
Hello, we don't hear you.
Can you hear me now? Hear me? Oh. Can you hear me now? Still not. How about now? Can you hear me? Hello? Still not? Hello, hello, hello.
We still don't hear you, Dov. Is that?
Wait.
It
How about
was
now?
coming out over HDMI earlier.
Maybe we need to check the sound from the Zoom. No, the Zoom directly, not the
Yep.
the audio. And
Try again, Dov.
maybe the sound is on zero on the screen.
Recording in progress.
All right, can you hear me?
Yes.
All right.
Remove the mic.
No. Okay, we may have.
Go ahead, Dov.
Okay, I hope we don't have a echo. Okay, so I'm the final speaker, I guess, and I will be discussing the ethical, the social challenges of the metaverse. Building off of what's been said earlier, I will maybe touch on some of the things that Raul said and some of the things that Marco said. But I should apologize. This is a little half-baked. There was a little misunderstanding on my end in terms of when we were going to start, but it's my fault, and I will take full responsibility. Okay, I want to preface this entire talk with, if anyone has seen the incredibly cringy advertisements that Horizon Worlds put out, that Meta put out right for Valentine's Day, much of what I'm going to say may seem to be incomprehensible, that after $70 billion of effort, this is as far as Meta has gone. I don't know if anyone's seen it.
Let's kick things off with some
Just so you
breakup
know.
stories. Who's first?
I'll go. My ex broke up with me via text, using emojis.
Let's kick things off with some breakup stories. Who's first?
I'll go. My ex broke up with me via text, using emojis. I got a broken heart, a crying face, and a thumbs up.
For real?
That's not...
All right, so this is what $70 billion gets you in the metaverse. Some of the things that I will talk about may seem to be a little out there, but I'll nevertheless, I thought that it was important to mention the elephant in the room, that at least Meta's version of the metaverse is still incredibly sort of cringy hellscape of screeching underage children. But hopefully we will move beyond that. Nevertheless, when we're thinking about some of the ethical, legal, and social implications of this emerging technology, we can definitely gain from thinking about where we failed in the past, particularly in the area of social media and the internet. So, for example, a lot of the privacy issues, we can learn a lot from how insecure the internet is and how long it took us to get a secure or relatively secure internet. That was a long time coming, and of course, we'd like to develop a metaverse that doesn't have those sorts of issues. Additionally, another issue associated with social media has been sort of this echo chamber of social thought. It's created sort of these little fiefdoms of right and left and whatever, and that has done less for freedom of information and freedom of speech than we would have liked. And again, thinking in advance of how we've gone wrong will help us develop a metaverse that is better. In addition, you can think about the biases that AI has created. Of course, we're getting past this relatively quickly, but thinking about how technology has been implemented without thinking about some of these sort of basic sort of issues that have come up in the past, it's very helpful to think about having something that's ethical by design and secure by design. Other issues include content moderation in social media, thinking about how to do content moderation in the metaverse. Again, it's the metaverse again is a hellscape of screeching children for the most part, at least in the corporate metaverses. And to think about how to moderate the content that's getting put up there in advance rather than doing it as an afterthought is a very important sort of effort. There was some discussion of the issue of incompatibility, these walled gardens that we have in our smartphones. Either you're on Google Play or you're on the Apple App Store or whatever, and this incompatibility between applications and applications that are made for some platforms and not for other platforms is again something that we'd like to try and avoid for the obvious reasons. And finally, the loss of public spaces. This is a big concern in terms of switching our reality over to a digital reality, where we would think we would have a greater opportunity to speak, but if everyone is a speaker, then no one is really listening. So again, this is another issue that needs to be taken care of by design and not in a retrospective analysis. So just to give a couple issues that I think came up in the area of the ethical and the social implications of the emerging metaverse. And again, just a handful of them. So of course, the digital divide. If anyone's seen Ready Player One, and I assume everyone in the room has seen Ready Player One, you will have, if there is a world that occurs within the metaverse, then we always have to consider the fact that some people may have sort of like duct tape together sort of interactions with the metaverse, while other people will have very high-end sort of interaction with the metaverse, and their metaverse sort of experience will be very different one from the other, and their abilities to do one thing or another on the metaverse will be very different compared to their peers. And so this is a huge issue, particularly because the technology isn't necessarily so cheap. You don't just, there are options to get into the central end of like via 2D via the laptop, but if we're going to think of this as an XR conference, thinking about XR, then of course there are these sorts of issues that will come up. there's some interesting issues with labor and employment, and this gets more into the legal issues, but also social issues. And of course, there is this concern of exploitation of the content creators, both within social media, but also now in the metaverse. The opportunity for the creation of sort of these Amazon Turks, what has become known as Playboy, this idea of unpaid labor that you are thinking is play for me, the content creator, is play, but for the person who's exploiting me, it's labor, and they're getting essentially free labor. And there's an interesting book that's out that sort of goes into sort of this whole area of sort of this uncompensated labor that goes on in social media, and of course in the metaverse. If we're interacting with your employment via the metaverse, and you have to be concerned about full body tracking and other sort of tracking options, and you know, you think you have the privacy of being at home or in wherever you are, but the technology allows for intricate sort of tracking. There are concerns with labor rights within the virtual workspaces. So idea is that, you know, oh, it's sort of play, and so I can work you harder, or you're more willing to work harder. But of course, we have to be cognizant very much of sort of these issues that in reality you are doing labor. There are also, and I'll skip a little bit, of course, there's also this issue, particularly in the law firms that are opening up offices within the metaverse. There's a huge KYC issue, because anyone can walk in and pretend to be anyone, and in reality there's someone else. And of course, knowing your client and knowing them in a real way is much harder on the metaverse, unless as it is to some degree on the internet. But it's the avatar aspects of the metaverse and the immersive sort of aspects of the metaverse sort of enhance those sort of concerns. This has already been mentioned, but of course there are the sort of economics and the ownership aspects of the metaverse, the protections for assets on the metaverse, taxation in the metaverse, the idea of moving the very unenvironmentally friendly fashion world to the metaverse. It's already done. Balenciaga, Nike, Adidas, everyone's on the metaverse. And of course, there are sort of the positive aspects of doing that as well. But of course, with fashion, there's always also negative aspects. There are, of course, developmental concerns with regard to children, having age-appropriate design. And again, if anyone, I mean, my only interaction with the metaverse, again, is only in the commercial metaverse. And I know that everyone in the metaverse is an 8-year-old boy. And so there are concerns that it's not necessarily an age-appropriate area for these children. And of course, there has been sort of sexual abuse on the metaverse, and so protecting these children from predatory behavior in 3D spaces where they seem to pretend, where it seems to be a safe space, in reality it may not. And of course, that will have social and emotional impacts on the development, educational impacts on the development, particularly if educational institutions tend to push towards the metaverse and sort of promote the metaverse, where the metaverse, again, may not be age appropriate. And of course, there are issues with family structure and parenting, the virtual context, whether or not this is just another high-tech babysitter for your children, and how that will sort of turn out. To that end, as a high-end babysitter, you have to consider sort of the escapism aspects. And of course, you think about Ready Player One again as sort of indicative of this. When the virtual life becomes preferable to the physical reality, you know, this becomes perhaps a social issue. People will be checking out from their physical communities. They'll be checking into these virtual communities. What does that mean for our physical communities? What does that mean for those of us within our physical communities who cannot necessarily check into the virtual communities? Will they be left out? Particularly the elderly and those who may be poor or whatever will have limited access to this sort of thing. You want to also not forget your sort of physical world responsibilities. You know, this isn't Westworld where you can go off and, you know, ride on cowboy and everything like that, but you have physical world responsibilities that cannot be forgotten. And of course, there has to be some sort of discussion about whether or not the metaverse is a real reality or whether or not it's a virtual reality, and what does that mean. And I think there's a great book by Chalmers called Reality Plus that sort of goes into these sorts of issues as to whether or not a virtual reality is a real reality, or if it's not a reality, then what is a reality. And so, of course, this is a very sort of philosophical but also social issue. Of course, we can't go anywhere in the metaverse without thinking about the mental health and the well-being of the people in the metaverse. Not only is it an amazing tool to promote mental health and to have access to therapists and the like, but it can also be very detrimental to mental health. There's concerns of addiction, compelling virtual environments that are more compelling than whatever miserable life you have. There is the concern, again, disassociation from the physical reality and physical communities. Like I said already, there's concerns about harassment online, exposure to extreme content, and of course, some sort of confusion between between your identity in the physical world versus in the virtual world. Whereas in the metaverse, I may identify as a polka dot cow, but in reality, I'm a spotted giraffe. And of course, how does that work? Who am I in reality? And what happens when those two realities converge and merge and clash? What does that do for my sense of self? As always, when we're using sort of these immersive sort of technologies, have to be concerned about being nudged by the algorithms that are manipulating our lives already. In YouTube, we see nudging, in Instagram, we see nudging, but of course, in the more immersive environments of the metaverse, we are more likely to see a greater amount of nudging and a greater sort of ability to be nudged. Particularly because, because of the realistic nature of it and the immersive nature of it, you can better sort of reward sort of addictive sort of activities for more so for worse than for better. Of course, there are these concerns of whether or not my choices in the metaverse are my authentic choices, or whether or not I've been manipulated by some sort of algorithm. And of course, this happens in every world. In Amazon, I'm also being manipulated by the algorithm. And when I'm in video games, I'm being manipulated by the algorithm. But if we're looking to the metaverse to be a parallel reality, an alternative to what we're currently in, then we have to be much more concerned about being manipulated by sort of algorithms. And of course, privacy is clearly an issue. We have to think about whether or not there's biometrics. So Illinois has a very powerful biometrics law, BIPA, and that's something to be thinking about. Eye tracking, what does that reveal about me? Spatial mapping of our physical environments. Of course, we had this concern with Roomba doing that. This is a much more intense sort of thing. So again, privacy and data collection is clearly an issue that needs to be dealt with. And again, we want privacy by design, not privacy as an afterthought. I'm just going to finish up thinking about, what is and what isn't actual reality, and how that gets confused within the metaverse or within sort of an immersive environment. Does this challenge our perceptions of identity, existence, and absolute truth? Is there an absolute truth in the metaverse? What happens again when the virtual experiences become more desirable than my crappy reality? How do we learn to deal with that? How do we define human experiences within the metaverse when experiences are simulated? So for example, I wrote an article a couple years ago about the metaverse of food. What can it's Ramadan right now, and sooner or later there's going to be a whole bunch of fasts in both the Christian and Jewish religions. And so can I eat in the metaverse? Is that a violation of sort of these fast sort of principles? And what are these senses of reality? And of course, perhaps one of the most socially, ethically, and morally reprehensible concerns is, if it's not in the real world, does it really count? And of course, if you on Reddit at any point in your life, you would have seen a question pop up that says, if you were a doctor and you could do some sort of reprehensible sort of medical experiment on someone for the better of humanity, would you do it, and what would it be? Right? Given that there were no repercussions, pretend you're a Nazi. What would you do if there were no repercussions to being a Nazi? And what sort of miserable sort of experiments would you do on humanity? And of course, you could imagine this actually happening in a metaverse where, with enough data, you could do some sort of horrible experimentation. And you can argue, but it's not real, so does it really make a difference? And of course it does, when we're thinking about it, because it really does have an effect on us, who we are. And so again, this is just, I cobbled together at the last moment. I apologize. I wasn't really, I had some mistaken ideas about timing and everything like that. But these are just a handful of the many, many ethical, moral, social, legal issues that occur in the metaverse. Thank you very much for your attention. I directed to our Institute for Legal Implications of Emerging Technologies. This is an area that we're very much interested in, and I'm keen to interact and work with any and all of you. I don't know how many people are in the audience. Very keen to work with other people. My email is over here. I think I spelled everything right. You can look to Doron, who is a colleague of mine at Reichman University, so we can talk about these sorts of issues. So thank you very much for your time, and I appreciate the opportunity to speak in front of you. I wish I could be there. So thank you.